equivalent polar coordinates. All right, so in the previous video, we worked on plotting polar coordinates. And one of the things that we did was when we had an angle that didn't fall within our first revolution from 0 to 2 pi, we adjusted it either by adding 2 pi for those negative angles or subtracting 2 pi if the angle was greater than 2 pi. We found that we could, while changing these angles, still plot the same point. So we plotted theta equal to 5 pi over 3. So this point right here, for all intents and purposes, this point is represented as 7 comma 11 pi over 3. That's what we plotted, right? But it's the same thing as 7 comma 5 pi over 3. These represent the same point. Whether you got there going this way or you got there going all the way around, it doesn't matter. You'll still end up with this same location. This is what makes the polar coordinate system distinct from the rectangular coordinate system. In our rectangular coordinate system, there's only one way to address a point on the plane. Every point has one and only one address. It's the only way to get there. But with the polar coordinate system, every point has not just multiple, but infinitely many representations. 2 points that can be represented the same way in a polar coordinate system, we call equivalent polar coordinates. The word equivalent, right? Math, it equals. And here's some quick examples down here with 5 and pi over 2 angles. So the point 5 comma 3 pi over 2, go to 3 pi over 2, go outward 5, ends up right here. This is the same thing as going, instead of going forward 3 pi over 2, going backwards negative pi over 2. Want to make a quick point here that this negative pi over 2 is going to be 3 pi over 2 minus 2 pi. If you do 3 pi over 2 minus 2 pi, you get negative pi over 2. All right, and then you go to negative pi over 2, you go outward 5, end up in the same place. The alternative way of getting down to this point down here is I can go to positive pi over 2, and then instead of having a positive radius, I can have a negative radius. So I go the opposite direction, but then I make my radius negative, and I reach the same location. So those really end up being the different ways that you can plot equivalent points. If you start with a point, you can add or subtract multiples of 2 pi from the angle, and because it'll give you a coterminal angle, you'll end up right in the same place, right? Here's a quick example, right? You could subtract 2 pi, you get that negative pi over 2 angle, negative pi over 2, out 5, same place. I could also add 2 pi. If you add 2 pi, you're going around one time, you're going around some more. 7 pi over 2 takes you to right here, same terminal side, outward 5, boom, plot a point. The one that's a little more tricky is this last case over here. So what I want you to notice is really, we started with this 3 pi over 2 angle. If we wanted the radius to go negative, that means we have to go the exact opposite direction. The exact opposite direction is going to be the same thing, right? I'm just going to kind of draw that line there. Too messy. Draw this line here. The exact opposite direction is going to be subtracting pi from theta. So what I have drawn here is pi, right? Pi is half of the unit circle. We're not used to seeing the vertical half, but it's still half. If we take theta and subtract pi, that will have us going the exact opposite direction. And indeed, that's what happens right here, because pi over 2 is the same thing as 3 pi over 2 minus pi. 3 pi over 2 minus pi. And then make the radius negative. That's what happens. That's what happens for the other way we can make equivalent polar coordinates. So you can make r the opposite sign, and then add or subtract pi from theta. The reason that this works, this was subtracting pi here, but if I added pi to 3 pi over 2, I would go and I would end up here. So I'd end up with that same terminal side. Add it, subtract it. Really what it comes down to is this this is adding even multiples of pi will get you to the same coterminal angle. So if you add 2 pi or you subtract 2 pi, so I get add or subtract even multiples of pi, 4 pi, negative 4 pi, 6 pi, 112 pi, any even number of pi's, you're going to get a equivalent polar coordinate. And on the other side, when you make r the opposite sign and you're adding or subtracting pi, really what it ends up being is any odd multiple of pi. Because adding or subtracting an odd multiple of pi means you're going to be adding pi, and now it's an even number, and then you're making a coterminal angle. So adding or subtracting odd multiples of pi. So adding or subtracting pi, adding or subtracting 3 pi, adding or subtracting 5 pi, adding or subtracting 125 pi. Those are all going to give you the opposite direction. You're going to end up in the opposite direction if you add or subtract an odd multiple of pi. Right. So here I have this point right that I started with. I subtract pi from the angle to get pi over 2, and then I make my radius negative to go in the opposite direction, and bam, I have the point negative 5 comma pi over 2. All right, so let's practice it then. Let's practice it. Find 2 additional polar representations within each of the following polar coordinate. Find 2 additional polar representations each of the following polar coordinates. Write the coordinates in the simplest form. Angle needs to be between negative 2 pi and positive 2 pi. I'm going to go through on each of these and write those ranges down. Let's see, can I make this any smaller? Yes, I can. I'm going to write those ranges down with the denominator given. So, for instance, this guy, ooh, too much. 5, 7, 8, 9. It'll help us to have the ranges written down. So it should be from negative 2 pi to positive 2 pi. In terms of denominators of 5, that is going to be from negative 10 pi over 5. Debating if I want to. Give me a sec. Okay, I'm just trying to find a place to put it where it's not going to get in the way of the numbers. That's good enough though. So I finished writing the negative 10 pi over 5 to positive 10 pi over 5. For the denominator of 7, that's going to be negative 14 pi over 7 to positive 14 pi over 7. For 8, it's going to be negative 16 pi over 8 to positive 16 pi over 8. And for 9, it's going to be negative 18 pi over 9 to positive 18 pi over 9. Okay, I promise those will come in handy. So for the first equivalent polar coordinate, we're going to do the even multiples of pi. We're going to either add or subtract pi, not pi, 2 pi, add or subtract 2 pi. And for the second equivalent coordinate point, we're going to change the direction of r and then add or subtract just pi. Opposite r, add slash subtract pi. All right, so we have the point 5 comma 4 pi over 5. If I were to add 2 pi right now, that's going to immediately take me out of my range, right? I'm starting with a positive number. If I then add 2 pi to this positive number, it will certainly be bigger than 2 pi. So when you're doing this adding or subtracting 2 pi thing, um, and this is the range you're looking at, if you have a positive angle to begin with, you have to subtract. Otherwise, you're going to end up outside of the range. With negative angles, you'll have to add. With positive angles, you'll have to subtract. So I'm going to do minus, not that pen, this pen, minus 2 pi. So that's minus 8 pi or 10 pi over 5. 4 minus 10 is negative 6. So this is the point 5 comma negative 6 pi over 5. That's the first equivalent point. For the second equivalent point, we are making the sign on R the opposite. So R was positive to begin with, positive 5. I'm going to make it negative 5. And then 4 pi over 5. I can either add pi or subtract pi, and both of these will actually keep me within the range. So adding pi to 4 pi over 5 will be 9 pi. You'd have 4 plus 5 is 9 pi, or 4 minus 5 is negative 5 pi over 5. Either way, it works. I'm going to go ahead and, I don't know, let's see. Add. I'm going to add plus. Right, let's see here. Hold on, gotta change this pen. There we go. Plus pi. So now we have negative 5 comma 4 pi plus 5 pi is going to be 9 pi over 5. All right, let's do the next one. Negative 3 comma 10 pi over 7. I'm going to leave the radius alone for the first one. I'm starting with a positive angle. If I want to add or subtract 2 pi and stay within this range, I'm going to have to subtract here because I'm starting positive. So I have negative 3 comma 10 pi minus 14 pi is negative 4 pi over 7. Those are equivalent points. Now we're starting with a negative radius, and we're going to make this R opposite. So instead of negative, it's going to be positive. Positive 3. Positive 3 comma 10 pi over 7. We need to not go outside of 14 pi over 7. So if I add pi here, I will end up at 17 pi over 7, which is too much. I then need to subtract pi. That will work. Subtracting pi. So I have positive 3. Then it's going to be 10 pi minus 7 pi. So 3 pi over 7. Next one. We have 10 comma negative 11 pi over 8, 10 comma negative 11 pi over 8. Again, because we're adding or subtracting a whole 2 pi and we need to stay within a certain interval, this one we are going to be, because we're starting negative, we need to add 2 pi instead of subtracting. That'll take us too far down. You get 10 comma negative 11 pi plus 16 pi is going to be 5 pi over 8. On the other hand, making the R opposite sign, so negative 10 comma negative 11 pi over 8. And then I need to either add or subtract pi. If I subtract pi, I will have a negative 11 minus 8 is negative 19. Negative 19 pi is too small. It's outside my range. So I need to add pi. I have negative 10 comma negative 11 pi plus 8 pi is negative 3 pi over 8. All right, last row of this problem. For the first one, we have negative 2 comma negative pi over 9. I'm starting with a negative angle, so I'm going to add 2 pi here to make a coterminal angle. I have negative 2 comma negative pi plus 18 pi is 17 pi over 9. That fits within our interval, right? Doesn't get bigger than 18 pi. And then we could do a different one where we make the 2 positive instead of being negative. And then we can either add or subtract pi here, and both of them will end up working. I'm just going to subtract pi for fun. We have positive 2. Negative pi minus 9 pi is negative 10 pi, which indeed is within our interval because it's not smaller than negative 18 pi. And there we go. So those are all, well, these are all equivalent. Those across are all equivalent. So that's one thing we can do. We can make equivalent points with no conditions other than the range. But then we can have some fun problems where we're making equivalent points with particular ranges and particular restrictions upon R. So for instance, we are given a point here, and we're told to find an equivalent coordinate where both of these things are true. So R greater than 0 means that R is positive. That's what that means right there. R is positive. And then the 0 to 2 pi thing is saying that the angle is between 0 and 2 pi. So the angle needs to be positive. It needs to be between 0 and 2 pi. As that relates to denominators of 4, which is what we're working with, we're looking at staying within 0 to 8 pi over 4. 0 to 8 pi over 4. So I can't add 2 pi here. That will make me go outside of my range. And if I subtract 2 pi, then I become negative, and that's not within the right angle range. But that's okay, because I'm starting with a negative radius right here, and I need R to be positive. So I'm going to do the one where I change R, and then I'm going to subtract pi. Change R, subtract pi. So instead of R being negative, I'm going to make it positive. And then 7 pi over 4 minus pi. I have positive 6 for the radius. 7 pi minus 4 pi is 3 pi over 4. 3 pi over 4 fits within our range. So there we go. That's our answer. Not bad, right? If it helps, by the way, on remembering, especially like the difference between these two, which one are you adding or subtracting even multiples or odd multiples when you change the sign on R? It's odd multiples, right? Odd multiples of pi when you change to the opposite side. So first of all, opposite and odd look like the upside down of one another, right? Like the mirror image of one another. Imagine that right there. The mirror image of one another, opposite and odd. And also you could think it's odd to change the sign on R. And just a fun thing to think about. All right, we have a coordinate point here, 7 comma 5 pi over 6. Find an equivalent point where R is greater than 0. What that means is that R is positive. And negative 2 pi is less than or equal to theta, less than or equal to 0. That means that we are within the range negative 2 pi to 0. We're looking at denominators of 6 here, so that's negative 12 pi over 6 to 0 that we want our angle to be in. R is already positive, so the only choice we have here is to add or subtract 2 pi, because we don't want R to be negative, we want it to be positive. If I add 2 pi to an already positive number, I'm not going to become negative. So clearly the option here is to leave R alone and then subtract 2 pi. Minus 2 pi. So you have 7 comma 5 pi minus 12 pi is negative 7 pi over 6. That fits within our interval, right? It's greater than negative 7 pi or negative 12 pi over 6. That's our answer. Last problem here. We have 1 comma negative 7 pi over 3. Find an equivalent coordinate where r is less than 0 and theta is between 0 and 2 pi. R less than 0 means that r is negative. Theta is between, green please, 0 and 2 pi. As that relates to denominators of 3, that means 0 to 6 pi over 3. All right, so I'm going to be doing the option where I make the sign opposite because I need r to be negative. So -1, that means I'm either adding or subtracting pi here, right? It's like plus or minus pi is going to be what we need to do. We just need to decide which of those we're going to do. We need our angle to be positive because it's from 0 to 6 pi over 3. So this is going to be a case where we want to add pi. So we have -1, comma, -7 pi plus 3 pi is -4 pi over 3. And wait, we're not quite there. This is still negative. We need this to be a positive angle. Our r is already fine. It's negative. So we don't want to do this trick again. We just need a coterminal angle. So we need the 2 pi trick, the even trick. We'll leave the radius alone and we'll add 2 pi to the angle. We have -1, comma, -4 pi over 3 plus 2 pi. So -4 pi plus 6 pi is 2 pi over 3. Boom. All right. Whew. Well, there you go. A lot of equivalent polar coordinate stuff there. In our next 2 videos, we're going to be talking about converting between polar coordinates and rectangular coordinates, and that'll be that. All right, I will see you in the next video. Bye.